really do care about it, they don't, because for them it's an economic issue. When you have, like say, an architectural program or mechanical engineering, you know you're going to attract a lot of students. It's going to justify, it's going to pay for the lights and overhead of the university and so forth. But the technology that we're talking about has not been recognized as a needed technology, but it's the fault of ignorance of people who have not really thought as to what are the implications of having trained, educated people who could really propel this technology to its maximum level. Now, the effort put in a master's degree program is going to be heavy. Heavy in the sense that there are lots of disciplines to cover. Obviously, you cannot train somebody to be an electrical engineer, but you could make them understand what are issues associated. And also, you cannot expect an electrical engineering understanding that they have to carry them into really doing analysis of, for example, transmission lines, transmission loading, and so forth. I'm an oddball in the sense that I have had experiences. What I'm thinking is, at least you really create a substrate of knowledge where these people realize where they need help, and they will form, let's say, entities that they could deliver all the services required. Because the chain cannot be interrupted. A solar power systems, let's say, alternative, I don't want to say solar power engineering, it's alternative and renewable energy systems engineering master's degree. It starts like a certificate program, 3 sessions and so forth. But at the end, what you're going to be is, you would be almost very versatile professional that has exposure to all these things. You may not be able to master all these things in, let's say, 12, 13, 14 months, but nonetheless, you would know a hell of a lot more than anybody else. And as the time goes by, you would learn more and more and more. At least you have the tools. And it's very essential for universities to realize that any country that decides to really pursue renewable alternative energy systems, they do really need that kind of a discipline. And that discipline just cannot come in one day. So you really have to devote time, energy. Fundamentally, you have to find resources to sustain and support. First of all, to do that, you have to train professors. I've done that in India. In India, they welcomed. 5 years ago when I went, I'm a visiting professor at Indian Institute of Technologies in China and so forth. When I talked to professors, and I gave them the curriculum and so forth, they said, let's start tomorrow. And quite frankly, I said, I can't start tomorrow. I've got to teach you guys so that you... So I spent 2.5 months compressed course, something like 6 hours a day, in summertime, and there is, during a vacation, and the government got in, and they created the programs, they paid the professors and so forth. So then having the books and so forth, it was very easy. I gave them PowerPoint presentations and so forth. So the whole thing started going on, and every year, once maybe, or two weeks a year, I go to each of these universities. I kind of verify exactly what you've done and so forth. So India is one country that, under the auspices of the electrical engineering, they have what they call special curriculum in solar and alternative energy systems. But solar dominates the alternative energy systems. So solar is like 90%, alternative energy systems becomes like 10%. Just be aware what goes on and so forth. Last question. Okay, architecture. I can read architecture, SDAU and architecture. I don't know what that means. Who wrote that? Okay, let me tell you, one of the most important things associated with deployment of solar power technologies in building integrated systems. When solar power is used in architecture, the best time to start is when you are starting the first sketch. Architects are essentially creative people. They're artists. Some of them who are really gifted, if you teach them, it is a material. How do you use it? You could use it as a window, you could use it as an ornament, but the whole thing is that they have to understand that good portion of this that you're using has got to be deployed in order to generate power. And then you have limitations. You have essentially physical, structural limitations. What you have to do is, no matter where you are, whether in the northern hemisphere or southern hemisphere, you have to orient your building. How do you orient the building? Are you just a ship like that? No, you could make beautiful pyramids and so forth, all sorts of plays you could have with it that really, when you look at it, it's beautiful. Instead of really putting curtain glass, you could use solar cells. Instead of using just ugly sort of cells like this, you could have solar cells which have different colors. You could have blue, you could have green, you could have transparent. Energies vary, but in terms of architectural use, you have to trade off energy production versus visual aesthetics. Those things are being done in the United States, in Europe, and so forth. In fact, some of the pictures that I showed you, they had curvatures and so forth. You know, these buildings are not designed to generate energy. They're designed to contribute to reduction of energy consumption. So essentially, architects, usually the biggest problem with architects is that when they're trained, to them is function, form, aesthetics. There's a big difference between German architects and the rest. German architects, they are civil engineers, they're structural engineers, and they look at functionality, not the form. Form becomes secondary. Whereas in Italy, it's just the reverse. That's why you look at these Italian buildings. They are beautiful, but they're not functional, not all of them. So essentially, in India, you look at this beautiful high-rise building and so forth. You go inside the elevator, you could put two hands in it. It's so badly taught. For them, convenience means nothing. Their kitchens are a couple of sinks, and next to the kitchen is the toilet. But when you look at it from outside, you think, my God, you're in New York. I would say, especially, Armenians have always been talented architects. Absolutely talented. You look at the monuments that we have, the creativity that these people had, not only now, over centuries, admirable. And the shapes are geometric mostly. So really, by using creativity, shape, form, color, you really could create monuments that I don't say they're architects, they're architectural monuments using solar power panels. In some instances, some of the pictures that I showed you, some architects, they come up with the idea, okay, instead of using curtain wall, I'll use solar. Well, that's dumb. Why? Because these things, by the way, solar panels cost less than curtain walls. People don't know that, you know, a 250 watt panel is like, I don't know, 60, 70 centimeters by 1.5 meters and so forth. It's like 30 inches by 65 inches. That's a panel. And the cost of it, when you compare to curtain walls are nothing else but tempered, and they have some coating on it. You could use those ones readily. They are no different than these panels, except they have really special hooks. So essentially, you could really use your imagination. Instead of using curtain wall, you could use that. But if you do that, you better have some consideration as to how, you're going to be interacting with the solar rays and so forth. So essentially, I would say it would be very important for architects to really take into consideration that solar integrated systems are very, very important, very viable. On the other hand, architects also have, across the world, some problem. The problem with architects is because their training is such that they are put in a position, they really define the shape of the building, but at the same time, the building is not just the walls. You're talking about mechanical system, electrical system, in fact, in some instances, control system. Now you're adding a solar to it. They have to really coordinate all the technologies and trades, so they really have to develop a sense of as to what it involves to tie in the electrical engineer with the solar power engineer, because that affects the solar power engineer affects the electrical engineer, because his panel, switchgear, distribution system is going to change. The way you really bring, for example, power either from the roof or from the yard, it would require underground conduits. How do you do that? That architecturally it doesn't interfere with the aesthetics. There are lots of issues, and it's the architect who's going to coordinate. In fact, in California, there are laws. They're called visual pollution. If you really have a building here and you want to put solar on your building and it looks like hell, you could sue them that it's a visual pollution. If you're in a condominium area, you want to put solar, you have to get consensus of people, because it becomes a visual pollution for some and aesthetics for others. Also, architects are not just designing buildings, they're designing parks, they're designing environmental, shall we say, systems and so forth. That's the place where they become very effective in making sure designing stadiums and so forth. Instead of just having regular open stadium, you could have bleachers that are totally covered solar cells, make it such that they're flat, so the orientation of what it is, it doesn't affect. It provides shading, it provides power. So essentially, there are a number of applications in architecture that make solar power use really very viable. So any other question? One thing that I'd like to ask you, I don't know, I don't believe that everybody but we have here, they were present all 3 days. In order to really give Professor Ambarian some idea as to what you got out of these meetings, and myself, I'd like to ask you if you could write maybe a 4 or 5 line. If you want, you could write a whole page. Let us know what you got out of these lectures, what did you learn, and how you think it would improve your professional outlook by the things that you have learned. We are going to hold, hopefully next year, if we have the opportunity, to hold an international symposium in Yerevan. That would be very different than what we had. It would not be free. It would be a little more costly for the locals, but a hell of a lot more costly for the visitors. We'll try to have not only a symposium, but also exposition. We'll have special speakers and so forth. The speakers would be, I have a number of professors that I work with and so forth, I could invite them readily from India, from China, from Europe and so forth. So we could have both an exposition, we could show them what we have, what we are doing and so forth. And at the same time, the intent is really to provide type of technologies that would show them that Armenia is not behind in terms of vision. And hopefully by then, if you could really promote development of maybe 10, 20 megawatt systems, we would be able to tell them that we are in the process of really planning for future. So essentially, it would be a major exposure for Armenia. So anyway, the reason I'm asking you to write that is for the university to understand what is the value that you receive from this very small lecture, this symposium, because symposiums that I conduct, there are thousands of people, 2,000, 1,500 and so forth, and they're charged for the same type of a lecture, $1,500 to $2,000. So consider that you're beneficiaries of that, because quite frankly, lectures like this are attended by professionals, by institutions and so forth. So I'm just looking forward that we will have the opportunity next year to have a much larger venue and exposition associated with it and so forth. So in the interim, I'll be working with Dr. Hampayan and other associates to see if we could really raise funds required to really make preparation, advertising, invitations and so forth. So that would be a major platform for us to show that we are present and are thinking about improvements in energy production, green energy and so forth. So anyway, thank you very much for attending. I really appreciate the white hairs around, the elderly people who really are so keen to learn what we have done and what's going on in the technology world. Artakcan, thank you so much. I would like to really especially extend my special thanks to ASEA USA that went out of their way. They provided some funding, very, very important. We had wonderful representative. Maybe you could say a couple of words, but essentially with the hardships that we had, we developed a web page, invitation, worked with AUA and so forth. We made this thing possible. We're hoping to do it at a grander scale next year. Thank you so much.
Okay, ladies and gentlemen, one more time, thank you very much, Dr. Kevorkian. And this is some kind of beginning of a longer process, I hope so. And the aim, as we were talking, it is going to have a really comprehensive renewable energy, solar energy, photovoltaic, large-scale program. But we have still things to do in this direction, and it is a really long process.
But by the way, if you write that little composition, it would mean a lot to us. Send it directly to Dr. Hampayan, AUA Artat.
Yeah, we will send you an email address to which we would expect you to write that few sentences. So we would appreciate your input.
The importance of your comments would be used to, we will send it to Ministry of Energy, Ministry of Renewable Energy, to various universities so that they would be aware that there is an interest that must be cultivated.
Okay, so at the moment, let me also announce one more thing. This is related again to educational program. If you are interested to learn about a program which is called MARUI, which is a coordination between a few universities to create a joint master degree program in energy efficiency and renewable energy, you are welcome to stay. If it is not interesting to you, you can go, but we can have anyway a break, and this break is having some refreshments in the hallway, so you are welcome to go there and take advantage of that.
Razmik, would you like to add a couple of words? You're the president of ASA. You put so much effort in it.
Razmik Garakhanyan is the president of the Amerikahai Ջարդարագետների, Ջարդարապետների միություն, American Scientists and Engineers of Armenian Scientists and Engineers of America. Please.
Thank you, Dr. Peter Gevorgyan.
My pleasure.
Thank you, Dr. Artak Hamparian, for accepting, for allowing AUA to be the host of this one-of-a-kind solar symposium that we have started. AESA, Armenian Engineers and Scientists of America, is very proud, along with other sponsors. They're all proud to have such a distinguished gentleman, Dr. Gevorgyan, to be our instructor, our lecturer, to share his knowledge, wealth of knowledge with us. This is a field that I think it's instrumental. The team, along with Dr. Hamparian, when we cooperated together to make this a reality, truly believes that the solar energy and renewable energy in Armenia does have a major role to play. Believe that, and we need to work towards that goal, and the goal is a very noble one. It's a unique one. Our website, by the name of Solar Hub Armenia, there is a reason for it. Hub, OAGA, Armenia becomes the hub for the engineers and scientists and the technology and the devices, hopefully in the future, the near future, that will be the center of this renewable in the region, and can provide professionals, can provide services, and can also provide the devices to meet the solar and renewable energy technology needs. So we all hope for that, and again I thank both gentlemen here, Dr. Hamparian and Dr. Gevorgyan, and your attendance, and your encouraging comments, words, and participation. It means a lot. Thank you very much.
Դուք եթե իմանաք Ռազմիկի գործերը ինչ էր արել, իր ճամփուսը է, իրանց ֆոնդերից օգտվել է, եւ ճիշտ ասելով ամբողջ այդ ASA-ին հաջողել է, որ այս համայնքը ես եւ ասա դասախոս եմ, բայց ինքը արժեքն է այս բանի։